So let's continue with implementing retrieval. So let's split the file into two vertical frames. Well, where we left off, implement a function chunk text. It's done. So chunk the provided Wikipedia text into 200 character chunks. It's done. Initialize sentence transformer and quadrant client. Done. Create the collection named Python chunks. So we left off here. We need to finish these three steps. So let's finish the exercise. Create collection, create collection. I think it's better to split them into create collection could be joined with embed. So create plus embed and then query as a separate function. So it could be like that. The embed chunks it takes client embedder and docs. I'll put nothing. Outputs nothing. Actually, let's name it with convenient names. Ingest and retrieve. Ingest and retrieve. It's more convenient names for the RAG pipeline. So we also need to provide collection name. We don't have any mentions of, and also let's move up wiki text because it takes a lot of space on my screen. Collection name, which is Python Python chunks embedding size equal to 384. I guess it also takes collection name and retrieval also takes client, collection name, and query. Query is of type string, quadrant client, collection name of type str, docs is list of strings, returns a list of strings, and also top key, which is integer. We call ingestion phase client, provide client embedder, collection name, and chunks as docs. Top key, retrieve, client, collection name, query which is passed from outside, user query, str, query, and top k is equal to 1. So actually we need only one most relevant document. For ingestion phase, first of all, let's check if collection already exists. If client collection exists, provide collection name, which is a Boolean result, and if collection already exists, we pass in ingestion phase. Otherwise, client create collection, which takes collection name, it also takes vectors config, and which is vectors params size, embedding size, and distance of distance cosine collection created. So now we need to ingest. Ingestion comes with absurd method, client absurd collection name, points it also takes points, which is list of points, list actually from list comprehension of point struct. We need to import point struct as well. Point struct takes data. It's definitely ID, which is I. It is vector, which is V, and I guess it's meta or something like that. For I VT in enumerate from zip from docs let's look up on the previous exercise, which is 0.0 quadrant explicit vectors markdown. It takes vectors and texts, and instead of metadata, it's the name of the point is payload. So let's actually provide required arguments. below text of t, enumerate zip vectors and docs, and we need to get vectors for relevant documents which requires embeddings model. Embeddings model needs to be loaded. I guess it is. Interesting. Yeah, I guess embeddings model is lazy loaded, so it's better to hide it under else block, and I guess we are good for now. Embeddings model is imported from sentence transformers package. Sentence transformer, it's already imported. Now we need to provide model name or path, model name or path, model name, which is embeddings name. So we acquire vectors from colon embeddings model with method and code, where we provide list of strings, which is exactly what docs is. Docs is a list of strings, so we provide what it exactly defined in method definition. So according to method definition, we are good for now. We get vectors. We manually on low level provide points for quadrant client. So let's look at the exercise description. What else we need to implement? Create a collection named Python chunks. We did. Embed all the chunks and assert with sequential IDs. Enumerate. Let's also start from start from 0. Let's explicitly mention starting base, just in case, to remember enumerate function signature. The only thing is left is to implement retrieval phase. Actually, let's in background implement a script. Just ensure that we're good to go. Query the collection with explain the main idea. So explain the main idea, which is user query. And print the top matching chunks text. So as we know from the previous exercise, on retrieval phase we get I guess vector response or something like that. Vector response or storage response response something like that. We will figure out again from the beginning. So let's focus on the actual code, which is client query points, provide collection name, which is collection name. Secondly, we need query, which is the vector and for vector we need embedder model. So let's provide embedder model in order to retrieve relevant embedder encoding interesting. The interesting part that code we already have CentOS, so why do we need to instantiate embedder in the function body if we already have instantiated embedder and we just need to access it from function attributes, and here embedder if of is of type sentence transformer, which is fit mixin, peft adapter mixin. Let's just provide its final concrete name, sentence transformer, and here is the same type hinting sentence transformer, just in order to make IDE highlighting work. And code. Yes, now it works. It takes sentences as a list. It takes sentences as a list of string or just a string. And let's sentences. It's better to provide explicit names everywhere, just in case we remember exact method signature for the future. Encoding sentences, which is just a string with value query, collection name. Secondly, we need query, which is vector. And lastly, we need to provide limit. We need to override default limit, which is of integer of 10, but we need to provide it with top k from the method signature. So return value for this method is query response. Response query response. We need to import it from Quadrant Client models query response. It's the first import, and the second import is a point, I guess. Point something like that. So let's just split query response and access its method points, and we will figure out in place what's the type definition of the exactly value we're looking for. Query response contains of, it has attribute points, which is list of scored point. Points of type list of scored point. Response points So let's provide all the necessary imports. Here goes, here goes, here goes, here, response, scored, point. Now we have all the type hints, just in case we need to better orient in our code, because I like to provide type hints everywhere. It allows to better learn concepts of the library I'm working with, and also it provides a tensor from tensor I wonder where it goes. I guess it's from sentence transformers tensor, or from sentence transformers dot. I wonder where it came from. Tensor. Interesting import. From Torch. But we provide sentences as a single string. Never mind. So points and ID score payload. ID score payload. Top result, which is scored points first element. And what does task definition says? It says print top matching chunk text. Text is top result. Top result. Payload text. Payload get text. Return text. Retrieve. Oh, actually it's interesting part, because for now we just need to return points. Retrieval part returns all the found points by cosine distance, and we need to provide top key points. Top point is the first top key point. Top key point text, top text, and print text, print top result is not defined. Top result because the So I need to go. So I guess we just stop the stream. I need to do my work, and I will continue the next. Thank you for watching. Let's just Fiat VIP implementing 10th exercise, and I'll see you today or tomorrow. I will continue streaming on YouTube, so I guess in 14 hours, I guess within the next day, I definitely will stream again on YouTube. So thank you for watching, and please subscribe if you like that type of content. I will continue next day. Thanks.